All right, now we're looking at slide 50, example C, which asks us, what is the molecular formula of a compound with a percent composition 49.47% carbon, 5.201% hydrogen, 28.84% nitrogen, 16.48% oxygen, and a molecular mass of 194.2 atomic mass units? Again, we're asked to find the molecular formula. So what is the strategy here? The first thing that I do is that I assume I'm working with 100 grams of the compound. And then that converts my numbers from percentages into grams. So now I have 49.47 grams of carbon. I have 5.201 grams of hydrogen, 28.84 grams of nitrogen, and 16.48 grams of oxygen. Then I convert those from grams to moles using their atomic masses off of the periodic table. So 12.01 grams for carbon, 1.008 grams for hydrogen, 14.01 grams of nitrogen, right? All of these in 1 mole, and 16 grams of oxygen. So I take each of these is going to be a division problem, and I end up with 4.119 moles of carbon, 5.160 moles of hydrogen, 2.059 moles of nitrogen, and 1.03 moles of oxygen. Then to get relative numbers, I take each of these and divide them by whatever had the smallest number of moles, 1.03 in this case. Okay. And that is going to give me, in this case, I do 4.119 divided by 1.03. Comes out as 3.999029126, right? That's close enough. That means I have 4 carbons. In this situation now I have 5 hydrogens. I have 2 nitrogens and 1 oxygen. So when I combine those all together, that's going to give me an empirical formula, okay, because they're all whole numbers, of C4H5N2O. And at this stage in the class, you can put those in any order. If you put C4N2H5O, that would be fine too, or any other iteration, as long as the numbers, those subscripts, match the appropriate atom. Okay. But now I have to figure out what the empirical mass of this is. Okay. So I have to think to myself, okay, I've got now carbon. There are 4 of them times 12.01 AMUs. I've got hydrogen, and I'm just going to label this as empirical, right? 5 times 1.08, 2 nitrogens times its atomic mass, and oxygen. So now that is the masses of all the constituent atoms. To get the mass of that whole empirical formula, right, that's called the empirical mass, right, I have to add all those together. So I take my 48.04 plus 5.04 plus 28.02 plus 16, and that gives me 97.1 AMU. That's the empirical mass. So to find the molecular formula now, I take my original molecular mass, 194.2. That's my molecular, divided by 97.1. That's my empirical. And that gives me a factor of 2 that everything needs to be multiplied by to get my molecular. So I take C4H5N2O. Everybody gets multiplied by a factor of 2, and that gives me my final molecular formula of C8H10N4O2. And a nice way to check your work on these problems is you can then take this molecular formula, add up the masses of everybody, and it should be equal to 194.2. Okay, so a final answer here on slide 50, example C, of C8H10N4O2.